Okay, so I'm going to factor this polynomial. I need two numbers that multiply to negative 12 but add to negative 4. What are they? Thank you. So I'm going to have x squared minus 6 and x squared plus 2. Thumbs up if that's okay so far. Great. Okay. So now I'm going to set this factor equal to 0 and solve it. I'm going to set this factor equal to 0 and solve it. So for this one, you're going to move the negative 6 over, so you'll have x squared equals 6. And what do we do to both sides? Yep, square root it. So my answer will be plus or minus square root of 6. I need two answers because this is a degree 2. It's quadratic right here. So you need two answers. For this one over here, you're going to move the positive to the other side, making it a negative. What kind of answer are you going to get? Imaginary. Because when you square root it, when you have a negative under the square root, it's going to become imaginary. And then you have square root of 2. So this is your answer. Imaginary numbers always come in pairs. So you have two of them over here. So guys, today we are going to be looking at complex zeros. We got zeros that are complex because they have an imaginary number. That's what we're going to be looking at today. And it's already stuff you know how to do. Now guys, let's go backwards a little bit. I have my zeros. How am I going to do the factorization? Now normally you have pretty answers like x equals 3 or x equals negative 5. If I were to write the factors for this, what would it be? Yep, x minus 3. What would be the factor for this one? Yep, you just did the opposite, right? Okay, so guys, look, same process. Same process. How would you turn this into the factors? What would this one be?
X plus square root of 6.
Exactly, and this
X
one?
minus square root of 6.
Exactly. What about this one?
X plus I square root of 2 and x minus I.
Perfect. That's how you do the factors. So if I say give me the factorization, that means I need all of the factors. These are your factors. These are your x-intercepts, your zeros. Okay? Let's try another example. This one is a little different because your leading coefficient is a 4. Here, your leading coefficient was a 1. That's why I could go straight from the table to my parentheses. Here, you still need to do an eye chart. Two numbers that multiply to negative 32 but add to 31. What are they?
32 and 1. Negative 1 and 32.
Perfect. So I'm going to have to do the grouping method because my leading coefficient is not 1. So I'll have 4x to the power of 4. I'm going to rewrite 31x squared as 32x squared minus x squared. And then the minus 8 will stay the same. And you split it down the middle. What can these both be divided by? Yep, 4x squared. So that is on the outside, and you reduce it. This will be x squared plus 8. Divide these both by a negative 1. So this will be x squared plus 8. Since these match, that is just one of your factors. And what is on the outside are your other factors. Now, I'm going to stop here and let you guys solve it. Ready, go. Okay, so if you solve this one, perhaps you notice that this is a difference of squares. So maybe you broke this down into 2x minus 1 and 2x plus 1. From here, it's pretty easy to solve. This gives you x equals a half, and this one gives you x equals negative 1/2, okay? Now, if you didn't recognize that this was a difference of squares, maybe you just solved it this way. Set it equal to 0. You add 1 to the other side. Divide by 4. So you get x squared equals 1/4. And then you square root both sides. So the square root of 1 is 1, and the square root of 4 is 2. So that's how you get your two answers. And you always have plus or minus your answer. Is that okay, guys?
Was that the wrong way to do it?
I think this is, well, you could easily see this see this in your head.
So that's the long way.
I think
Just
they're both.
Just to make sure.
There's
you
two
know the correct
ways.
way.
Two ways. You could recognize that this was a difference of squares and write it like this and solve, or you could just solve. Okay? Whoops. All right, this one, we're gonna set it equal to 0. So you get x squared equals a negative 8 when you move that positive 8 over. You're gonna square root both sides. You should get x is equal to plus or minus 2i square root of 2. Now, if you put plus or minus I square root of 8, you needed to simplify this. So to simplify the square root of 8, this is 2 times 4, and 4 can be broken down into 2 and 2. So here's a pair of 2's, that's where it went outside. So it goes 2i, and this is left inside. That's how you get 2i square root of 2, okay? And notice again, guys, imaginary numbers always comes in pairs, okay? So if you have 2i as one of your answers, then you must have negative 2i as one of your answers. They always come in pairs. I'm gonna put the answer up on the board. Don't peek until you're done. Now you gotta solve this one. Move the positive 4 to the other side, it becomes a negative 4. All right, class, are y'all okay with this?
Yes.
Okay, all right, now you have the zeros. Now we're gonna go backwards and I'm gonna go back and get my factors. So look what I'm gonna do. The formula is always x minus c is your factor, where c stands for your answer, okay? So guys, for this one, it'll be x minus, your answer is right here, 5/2, and you bring that denominator to the front. So this is your answer, 2x minus 5, that's your factor for this 0. For this one over here, it's always x minus, you put your answer in here, 2i, that's one of them. Your other one is x minus, you put your answer in here, negative 2i, so what does it become? A plus. So guys, these are your factors. Make sense? All right, let's go ahead and fill in some notes. So the fundamental theorem of algebra, it says when you have a polynomial of degree n, where n is greater than or equal to 1, it has at least 1 0 in the complex number system. A complex number is a number written in this format, a plus bi. And any real number is a complex number. So for example, sometimes you solve and you get x equals 3. This is a complex number because you can write 3 as 3 plus 0i. You can ignore this because it has a 0. However, you can write any real number as a complex number by adding a 0i to the end. Yes?
So why would you remove the I though?
Because 0 times I is just 0. But this just goes to show any number you can think of, you can write it as a complex number. So if you think of pi, you can make it complex by writing it like this. Complex numbers all have this format, okay? So let's go ahead and talk about the linear factorization theorem. So if c is a complex number, so let's say you get your answers and you get plus or minus 2i, like we did in the last example. That means x minus c is your factor. These are your factors. Does that make sense? All right, let's go ahead and do a problem. Imaginary answers, they always come in pairs. So, before we start, if you have a 0, a plus bi, then a minus bi is also a 0. Imaginary numbers, they're always going to come in pairs, okay? So if this is a 0, this is a 0. So guys, since imaginary numbers always come in pairs, what also should I have?
Negative 3i.
Perfect. Now let's go ahead and write the factors. Remember, the format is always x minus c. So for this one, x minus, and your answer is 5, so you put in a 5. That's your first factor. This one is x minus, and you put in your answer 3i. Your last factor is x minus, and you put in your answer negative 3i, so how should I write it?
X plus 3i.
Yep, x plus 3i. All right, now we are going to multiply the complex numbers first. Okay, that would make it a lot easier. So everyone, please follow along. X times x is x squared. X times 3i is 3ix. Next, negative 3i times x is negative 3ix. Negative 3 times a positive 3 is a negative 9, and I times I is I squared. Do you guys remember what I squared is equal to?
1.
Negative 1. So guys, look, I'm not going to erase the minus or the 9. I'm only going to erase I squared and replace it with a negative 1. All right, do you guys see what cancels?
3ix.
Yep, this complicated part cancels out. So we're left with x squared, and what does this become?
9 plus 9.
Exactly. So notice, whenever you multiply the complex parts together, lots of things cancel, and it simplifies pretty nicely. Now we're going to bring down this third factor, x minus 5, and we're going to multiply. Go ahead and do this on your own. Look up when you have it. You're multiplying these two together. All right, pat yourself on the back if you got it right. Okay, nice. Good job, guys. All right, let's do the next one. We're gonna do a more challenging one. Okay, guys, based off of our notes, if 3 plus I is a 0, what else should be a 0?
3 minus I.
Exactly. So you need to add that in. They come in pairs. Okay, now let's write the factors. It's x minus, and then this answer, what will it become?
X plus 4.
Yep. This one, write it exactly how I am. X minus, we're going to put our answer in right here. Put parentheses, 3 plus I. These extra set of parentheses are important. Now we're going to do x minus, and we're going to put that answer in here, 3 minus I. We're going to distribute this minus sign. So you will have x minus 3 minus I times x minus 3 what?
Plus I.
There we go. And I'll bring this down. I like to multiply whichever factor has an I like to multiply those first, because lots of things will cancel out. All right, guys, follow along, write this down. X times x is x squared. X times negative 3 is negative 3x. X times I is xi. Now we're going to move on to the second number. Negative 3 times x, negative 3x. Negative 3 times negative 3 is a positive 9. Negative 3 times I is negative 3I. Now we're going to move on to the last number. Negative I times x, negative xi. Negative I times negative 3, positive 3i. Negative I times a positive I is negative, and then I squared. Now, I can replace I squared with what? Negative 1. Don't erase that negative that was already there. I only erased the I squared. Can you guys see what cancels out?
The 3i.
Yep, the negative 3i and the positive 3i. What else?
Xi.
Xi and negative xi. Okay, great. So I have x squared minus 3x, and another minus 3x is minus 6x. And what do you think is going to happen to these numbers? What will they be? 10. Good. Plus 10. Now, don't forget to bring down this x plus 4. Now, I want you guys to multiply this one out. Ready, go. When you're done, I want you to look up and check.